Chapter 4 is when we really began equations and identities. And I think you started to see that that's kind of important. The chapter began with the book basically proving to you that this identity held true no matter what. Cosine squared theta plus sine squared theta equals 1. This identity holds true no matter what. And there are two derivatives of this one. Maybe some of you memorized these other two, but me personally, I'd rather derive them. So I memorize this one, and then to derive the other two, I divide everybody through by cosine squared, and I divide everybody through by sine squared. And really and truly, you started to realize in this chapter that anytime you looked at a question and you saw anybody squared, you said, well, one of those Pythagorean properties or identities, it's all basically the same. Will any of those assist me at this moment? So, this one turns into what? 1 plus tangent squared theta equals secant squared theta. And this one turns into cotangent squared theta plus 1 equals cosecant squared theta. But you really only need to memorize that one. So we began equations and identities in this chapter with you. This is also the chapter that we had the parametric functions. And that was where you had this neat moment where you graphed, was it x and y? Yeah, it was x and y. X equals -1 plus 5 cosine t, and y equals 3 plus 2 sine t. And we just said, put your calculator in parametric mode and graph it. And you all oohed and awed because you saw you were graphing what conic? An ellipse. An ellipse. Okay? And so you should be able to recognize that these type of parametric functions do create ellipses. They also can create circles, and they even can create the other conics as well. The important thing to understand about this is that these numbers are what? The center of the conic. So this conic would have a center at -1, 3. Okay? It would have a center at -1, 3. And is this one an ellipse or a circle? An ellipse. How do you know? Because these two numbers are different. It's just like conics was last year. When you had different coefficients or different denominators, that was the ellipse. And when they were the same coefficient or the same denominator, it was the circle. And is this an ellipse that's taller than wide or wider than tall? Wider than tall. Why? Because the bigger numbers in front of cosine, and cosine is basically our x. So the graph of this conic would start at the center of -1, 3. We'd move how much left and right? 5, because it's in front of cosine. We'd move 5 left and right. And how much up and down? 2. 2 up and down, and we would have our ellipse. If these two numbers were the same, it would be a circle. If you wanted to put this into an equation of an ellipse, you're basically trying to eliminate the parameter, okay? And eventually, you're going to pick up your Pythagorean property up here to help you. You're going to pick up this Pythagorean property right here to help you. But what you first do is solve this equation for cosine and this equation for sine. So, what do you do with x? Add 1 and divide by 5, and then you'll have cosine t. What do you do with y? Subtract 3 and divide by 2, and then you'll have sine of t. Then, since we proved that this formula, that cosine squared of anything plus sine squared of that same anything equals 1, we substitute, instead of cosine t, we put x plus 1 over 5, and then we square it. Then for sine, we do what? Y minus 3 over 2, and we square it, exactly. And when we're done, we basically get x plus 1 quantity squared over 25 plus y minus 3 quantity squared over 4 equals 1. And there's that ellipse we knew was going to be there.